So today I'm going to look at this old Mac G4. I've had this computer for many years. It's been sitting in my garage for the past 15 years, maybe a bit longer, since I got my 2008 Mac Pro. This is the last time I used this machine. And it got put away in a working condition complete. So it should just be a case of getting it out, plugging it in and using it. However, it's not done that. Now I did actually open it up, vacuum the dust out from inside and that sort of stuff to make sure there's no dust that's going to be in there, which is shorting things out and blowing things and what have you on first power up. But it's still dead. Just turn the power on. It's drawing about 1.2 watts and it drops down slightly and hovers around like 900 milliwatts or so, around that sort of number. It's going up and down a bit, which makes me think the power supply is trying to start failing. If I push the power button in the front, nothing happens. I'm pretty sure the power supply has failed. So I think, because there's a switch mode power supply, I need to get this power supply out and try and see if I can get it to work. So the reason I'm doing this is because I need to recompile some software which I think is on this machine. I'm not completely sure it's on this machine. Many years ago I co-authored some software with another guy called Mark. This is where S&M software comes from. We actually had some software which was used on hotline servers as a bot, which basically managed the servers for you. You could kick people off and things like that, and you can have set up rules and automatic help systems and things like that. It worked quite well. Hotline is basically dead, but there are still a couple of servers out there, and someone actually purchased the license to the software, which hasn't been sold for 15 years. Found that, hey, you can't register the thing. So I can still generate a serial number for it, barely. I actually even had trouble doing that. Problem is when the software does the checks for the serial number, it's failing because the website which it used to go to do the checks to make sure it's a valid serial number doesn't exist anymore. I could spend $30 buying that domain name back if it's even available. It probably still is available somewhere. I could probably get a domain name back and then reconfigure it and get it to do the checks and work around that problem. But it doesn't really make sense to spend $30 to buy a domain name and then set up a website, or part of it anyway, in order to sell a $20 license. Doesn't really make sense. I'm trying to work through this whole system, but part of it is this machine, I think, has the software on it. I think this is the one I developed it on. I'm not 100% certain. This is the oldest machine I've got here, I think. I don't think I've got anything else. I'm pretty sure this is the one I did it all on. And if that's the case, then the software's on here and I can recompile it without those checks in it for the valid serial number information. Right, I can just bypass all that stuff and not worry about it. But first I need to get this machine working. The guy's been waiting for weeks because I injured my back and stuff like that, and that caused me some problems. And I couldn't actually pick the machine up, couldn't get off the shelf, that sort of stuff. So anyway, now I've got the machine out, but it's dead, which doesn't surprise me, to be honest. But anyway, we're going to pull this thing apart, take the power supply out, and we'll see if I can fix the damn thing. So part of the problem with these is that the plastics are getting quite old, and this has always been a bit dodgy for the latches. Trying to get it open has always been a bit tricky. I remember having no end of trouble years ago trying to get this open, because if you leave it too hard you end up breaking stuff. But you also need to get the latches to release. Here we go, got it. Right, it's got the plastic latches here, and one of them's already broken off from over here. So it's only actually got 2 or 3 latches holding it shut, but it's not a great fit. Now I have actually vacuumed this out already, but it's still quite dirty inside. There's the power supply, I want to get that out, and thankfully it's just a few cables which I can get to quite easily. So basically we've got some screws on the back here, we've got a bracket here to undo as well. Then we've got the power cables which go to the hard drive down here. Take that out. And then we've got one that goes to the logic board itself. Like that. Now this did actually have a battery in there, lithium thionyl battery, down there in the original holder. That was a battery that I put in it 20 years ago maybe. And it hadn't leaked. I've taken it out now, it's dead flat, completely flat. There's no leak or anything from that. So we've got all these cables here, which I need to sort of fish out of here. How's the fan connected up? There's a little plug there. Okay, so that's a fan plug. So I can get that out. There we go. That goes to the power supply. This goes to the power supply. So I'm only doing this to get the software. Now I do actually have the software still on my new machine. The problem is it's so old, the compiler doesn't like it. I'm going to have to spend weeks basically re-engineering the software. I don't want to go there. I'd rather just boot up on an older machine that I developed the software on, fix the problem it's got, generate a new version, and then put it on the website and say, here you go, and replace it. I don't even care about the software licensing anymore. I just want a version out there which works. I could probably even give it away, really, to be honest. It's probably only going to be appealed by half a dozen people on the entire planet. And that's not even locked in properly. What's that doing? That should be through that slot. That's not even installed properly. What on earth was I doing there? It's not even installed right. Let's pop this front panel out, if I can. Try to. Wow, the dust on that. Yum. That should be slotted in there. Wow. Anyway, I'll slide all this out. I'll come back once we've got the power supply out. Just take these screws out from here, and I think then I can slide the power supply out. Now I can get this hulk of a machine out of the way. Mind you, it's not as bad as a G5 or the Mac Pros, so it's not that bad. It's very, very dusty. Okay, I'll wiggle those wires around some more. I'll come back once I've got it out. Okay, power supply's out. Rather dirty. I probably should have cleaned this thing before I put it away in storage, but yeah. Right, so I was giving it a quick vacuum to make it a bit more, a bit less unpleasant to work with. So let's try and get this thing open. It looks like it's got like a U-shaped housing, which it will slide out from. That's what it appears to be. So let's get all these screws out that appear to allow that. And we'll see what we're dealing with. That may or may not need to come out, but I'm trying to take it out anyway. No, they could have stayed. I think I'll put it back on again, as I'll forget where it goes. Okay, that might be all I need to take out. Maybe. No, it's not shifting. Those ones are supposed to be for the fan, so they can stay there. Alright, well, let's try that now. No? Oh, there's something happening. There's a bit of movement. Let's clip this lead off here. Okay, there we go. Now we're getting somewhere. Okay, that's just as disgusting in there. I might go and give that a vacuum as well. These capacitors could be charged because I've had the thing plugged into mains before. First glance, I'm not seeing any bad caps. So it's slightly better again. I'm going to have to do that a few times I think. It's got a connector over here, red and black wire, red to this side. Quite a bit going on there. Also got this top board here and the bottom board. So I think I'll take the bottom board out. Top board looks like it's like a main AC smoothing and filter board, so that's probably less important. It could be that, not likely, but it could be a filter board. It's possible. It's more likely to be either this board over here or this board over here. So I'll take the bottom board out. Should I shut these capacitors first before I start touching stuff? Make sure they're flat. That'd be a wise thing to do. There it is there. Yeah, it's fine. That's flat. And another one over here. Probably nothing. Yeah, flat. Okay, so the main bolt caps are fine, so it's safe to touch stuff. That's always an important check. If you're messing with power supplies, they can give you one hell of a zap. If you're not careful, you have to really think about what you're doing and make sure you're not touching things which are inappropriate and that sort of thing. So if you ever do power supply repairs, check that it's safe to touch stuff, because if you touch these and they're charged up, that's, in my case, because it's a 240 volt supply, that's well over 300 volts DC on those caps. So it will give you one hell of a zap. You might have to sort of lay it all out on a bench or something, I'm sure. Everything's soldered. Makes it a bit hard to work on. Actually, this bulk cap here, that one, that is bulging. Now normally it's a bit hard to tell because you've got the plastic caps, and the plastic caps do look bulged. You just give them a poke and a feel. That one's dead flat, this one's bulged. This cap is gone. So it could be that. Usually it's a smaller cap that's gone, not these big ones. These big bulk caps don't tend to be the problem. It's usually the smaller ones, usually on the actual controller for the switch mode supply chip and the switch mode controller. It's usually those ones just go. So I will actually have to go around and try and measure all these caps. There's also a fuse on that board there, but I know that's working because there is some kind of current draw. I can check it anyway to be sure. And there's a, well, it's like a fusible resistor over here. We'll check those. Let's make sure they're good. They probably are, but just to be thorough, let's check the fuse. Yeah, it's fine. So it's a shame this is going to be a bit hard to deal with because of the casing setup. I'm trying to open it all up. That cap there's bad, right? Definitely bad. Whether or not I've got something I can replace it with, don't know. That one's okay. On the surface it appears okay. None of the others I can see are bulging. This has been repaired before. There's some flux residue around here. Interestingly. Anyway. What's that? Should this fall out like that? Wow, really? This fell out. Where was that? It's probably not a good sign. I think it was there. Oh, look, it's blown. Aha. Aha. Found a problem. That's half of one of these. And it's all cooked. Okay. So it was there. See that? That one there's gone as well. So I think those protection circuits have gone. Yeah, that's all just burnt up and gone. Just there. And it had heat shrink around it. There we go. Here's the other half of it. Wherever that used to be, there's two of them. And they're both fried. So, that's some kind of protection. So with the capacitor, it's a 200 volt 820 microfarad. I've taken out what's left of these MOVs. Yeah, so I'm going to see what about if I've got something to replace this with. It's a shame to, you know, invest that much money in it, but, you know, I need to get the job done. Right, let's see what's this other capacitor's situation is like. Yeah, it looks alright. 728 microfarad. It's a little bit on the low side, but it's there. Let's check some of these other ones. Really, I need to check every single one of them. 3000 sounds alright. Resistance looks alright. I think it's that one. Looks okay. Usually it's a small cap which goes bad. That looks alright. 1.9. It's getting a little bit higher. 2.9. That's getting up there. That's one I'd be suspicious of, definitely. Just trying to figure out what the legs are. That looks alright. I'll do this off camera. So on this board over here I've got a few like orange caps. And they're all measuring quite badly. It's like 8.7 ohms, 10 ohms, that kind of thing. Is there, and there. Kind of see them down there. Those will measure badly. Out of the caps there's 5 that I can see which I don't like the values of. The rest seem kind of okay. And interestingly, this one which is bulging, it is definitely bulging. This actually tests not too badly. Now, this actually tests about the same as the one that's in circuit still. Right. Tester says good. 727.19 ohms, I should say. So, but this one's bulging. It's like, I don't think this is good cap. So I fired up the IT28. I've hooked up this cap which I pulled out, but one which has got a bulge in it. It measures okay for capacitance. Well, it's slightly low, but it's there. It's within sort of 10%, I suppose. So I'm going to check leakage on it. So that's why I fired this up. So I've got it set 15 volts as a starting point. Let's check leakage. Looking fine. We'll bring it up and see if we can find any leakage. 50 volts. It's opening up. There's a 220 volt cap. Sorry, 200 volt cap. So I should be able to go up to 200 volts without any issue. $100 volts is barely going. Okay, that's going. 150. Struggling a bit. I'll do a comparison with a different one soon. Now the caps I've got here, I've got some high voltage caps but lower capacitance. I don't actually have exactly the right ones here, or something I could really substitute with properly. So that's 150, it did open up. Do 200. Then I'll do a comparison in a second with another one which I know is brand new and good. And 200 is opening up. So, yeah, it's not actually leaking, not really, it just isn't performing that well. So let's turn this back down, discharge it. Let's try on this cap here, which is a brand new one. This is a Nippon Chemicon, 450 volt though, but it's to give you an idea of speed. This is a much lower capacitance though, so it should actually be faster. So leakage, it's on 50, see it's opening up much quicker. 100. This is the quarter of the capacitance, so really it should be 4 times faster. 150. Yeah, so it probably is about 4 times faster, so I think it's on par. So I think we're probably okay. I might put that cap back in again. Even though it's bulged, I just need to do this one job with this computer. And I can probably get the right caps and get them in. If this works, I'll recap this power supply and restore it. But right now I just need to get the thing working. Right, I've replaced 6 capacitors and reinstalled the other original one. Plugged the fan back in again. Reassembled the casing basically. Yeah, we'll try it. Replacing those 6 caps could have fixed it. So we'll just base it on that first. Now I've got 2 multimeters set up here. One's testing the 5 volt supply rail, one's testing the 12 volt supply rail. In theory, if I've got this right, the green wire here is the turn on wire. So if I short between the green wire and the black one just there, that should turn the power supply on, if I've got this right. Okay, I'm pretty sure that's the case. So that's what I'll find out, I suppose. I'm pretty sure that's how it works. I could be wrong, but we'll try it anyway. What could go wrong? It's already dead. So we'll turn the power on, see if it goes bang before we do anything. Well, you know what I have to do first? I have to plug the wire into it. This one here, it's plugged in. Now I'll turn the power on, see if anything goes horribly wrong. It's doing very similar behaviour as it did before, with it fluctuating up and down. Also, there's nothing on these rails. Let's shove this across here. Nothing. So it looks like it's probably still dead. Let me check these things on this connection here and see if we've got any life at all on this connector. I'm hoping we do somewhere. Let's just probe them all. Should be anything on this one if we've got anything. Nothing. 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 This isn't looking very promising, is it? Try this in. Yellow. Nope. Got this orange one here. No. There's a white one there. Nope. This thing is completely dead. Blue. Orange there. No. Yeah, it's completely dead. Well, let's go to the end of the filter first. Let's do a logical approach. End of the filter system. Do we have AC on the end of this? We do. So it's getting out the end of that filter system. So it'll be going to the main board. So somewhere on that main board it's dying. Awesome. So let's check out these big bolt caps here first. See what we're getting. This is the one which I'm suspicious about. 156 volts with no ripple. So okay, although the cap's not in great shape, it's obviously doing something. It's not too bad. It's actually working. So alright, there's another cap just here. Let's try this one. Nothing. That's got nothing at all on it. These other ones are replaced down here. Let's try and get onto these. Point there and there. Nothing. Well, this isn't going well. So I've replaced all the small caps on this thing and I've got nowhere with it. I mean, some of the caps were definitely bad, but I've replaced all the small ones. The bigger ones I've left alone because I think they're probably fine anyway. They usually don't have that much issue, in my experience. What I'm trying to do now is still diagnose why it's dead. I've done some reverse engineering on this a little bit, just trying to figure out the circuitry and the switches and stuff like that. So it's got 2 switching ICs in here. One's there, one is there. Don't go poking stuff on power supplies if you can avoid it. Just out of habit, just avoid touching stuff if you can do it. Otherwise you might accidentally do it when it's powered on. So I figured out the power supply rails on each of those switches, and I've tried to trace back some of the circuitry, and I found like the trickle supply, like the bootstrap on it, and things like that, and the feedback from the actual transformers. Found those. So I'm going to just do some probing here, see if we can find out what voltages are actually on these chips. Now there's a UC3842 and a UC3843. One is rated for like 16 volts, one's rated for 8 volts or something like that. So the actual turn on voltages, that's the difference between them, otherwise they're exactly the same. I'm just going to probe on these pins and just see what we actually get. And if I don't have a voltage on those chips, and these gives me a direction to go in. I believe that's probably the case. I think I don't have a supply here. One of the caps, or a couple of caps I've already replaced, are on the supply rails to those chips. So I know those caps there are good. So that shouldn't be an issue with the caps. Normally it'd be an issue with the caps causing an issue with the supply rail, which means the chip doesn't start up. And that's not the case now. Well, it shouldn't be. So let's measure the voltages on here. Going to turn the power on. Now it's dangerous. And we shall probe onto the grounds. I can rest my hand on the casing, that'd be safe. So that's the ground pin there, 0 volt pin on that pin, and this one here should be a supply rail, and you've got nothing there. Okay, and we'll do the same on the other one over here. 0 volts there, supply rail should be here, and we do have something there, and it's jumping over the place. So we've got one of them is active, the other one's completely off. Now that kind of relates to what I was expecting to be seeing, is that this chip here turns on before this one, because this one's got direct feedback, whereas this one doesn't. So I was actually thinking that this one here would be the main one, but the supply going to it is jumping over the place, like the chip is trying to turn on but not making it. Let's have a look at the outputs. Output pin is pin 6. Pin 7 is the VCC pin, which is what I'm just probing on here, right, this VCC there. Pin 5 is ground, pin 6 is the output, and you see that it's trying to start. It's trying to run. Seems like the supply is a bit weak for it or something, so it can't quite boot. Stick it on there. Max is 4.71, minimum is 11.94. For 14.71 max, 11.94 min. That's what we get in there. Let's turn the power off again before I zap myself. It's jumping around a lot, and the bootstrap supply is not coming back up. Okay, I need to think about this. So I was just looking around the front edge of this board here, I was trying to trace around the triggering output from this chip, which one I've been checking, this one here, and trying to follow that triggering through to go to the transistor, because we're seeing pulses on the output of the chip. We were seeing something. We're not seeing anything on the transistor. I'm looking at this. It goes through this resistor here first, which is a 10 ohm resistor. That's fine. It goes through this parallel diode, another resistor here. There's a lot of corrosion just here, so I've just taken that resistor out because it looks really bad. I'm going to check it again now, but the colour bands are green, brown, brown, gold, which is interesting. We've now got that resistor out. I can probably check that diode too, because I couldn't check that before. So let's quickly do that, see if that's actually working. So 0.6, yeah, okay, that is working. This diode does have a bit of corrosion on it as well, on that leg, but it didn't look as bad as a resistor. So let's check the resistor. So I've got under the microscope here, so it's got green, brown, brown, gold, and you see the gold there. But this end is really corroded, basically the coating's all gone. You can see it's got corrosion there. These are both by the fan, so I think it's just been sucking in moisture, or maybe it's been bugs get in maybe, and I don't know. But so let's check the resistance value. Open circuit. Might be something to do with it. So a green, brown, brown, gold banding. Obviously the very last band, which would be the tolerance, is not there. So I found a 51.5 ohm. It said you have 51, but it's, you know, tolerancing. So I'm going to shove this one in because it's certainly better than an open resistor. And I'm wondering if this will fix our problem. It could just be corrosion rather than capacitors. At least it's got some new caps in there now as well. But we'll put this together and I'll bolt it together and see if it powers up this time. If we're lucky, it will. I'm certainly hoping it does. Now I'm not cleaning up any flux or anything I've done, because I want any of the repairs I've done to be traceable. Because if I clean the flux up, you won't be able to tell which bits have just been, you know, repaired and replaced and what have you. So I'm not cleaning flux or anything I've replaced. make sure that soldering's alright. Don't want to short something out, that'd be bad. Okay, looks alright. Right, you ready? Got any more magic smoke, you reckon? Right, power up. Oh, it's drawing 5 watts now. Oh, that's new. Grab the ground, and we'll grab the switching supply here. Bang on, 15 volts. Oh, look at that, that's running. And there, 0.2 volts. Okay, that's got something going on there now as well. Looks like supply is kind of working. Let's try shorting out across these terminals to see if it will turn on. Let's short across the green and black and see if the fan comes up. The fan has come up. It's working. The fan's running. Brilliant. It might be fixed. Right, let's try this. 3 multimeters here. Got the Keysight 1282A here. I'm going to use this to probe the 3.3 volt rail, which is the orange cable, and the 28 volt rail here. I've got this one on 5 volt rail, this one on the 12 volt rail. Okay, so I also need to get something to trigger it with, which I'm going to use this for. I'm going to shove this into the terminals to trigger it. Okay, power it up. Got some stray voltages, but that's not too surprising. Let's shove this in here. That should power it up. 11.6, 5.2. Okay, let's shove this one in here. 3.3. Oh, drop the thing. Get that back in. And 28. All the supply rails are there. Don't see from the 5 volt rail, there's no ripple on here at all. It's looking really good. So it's looking promising. Okay, so what I might do is actually check for ripple on these rails. Using this meter. Nothing, 6 millivolts on that one. Nothing on that one. And a 3.3 volt. .67 millivolts on that one, a bit higher. And you've got 12 volt rail here. 30 millivolts. Yeah, it's alright. Okay, well, the power supply is working. Brilliant. Let's get this computer up and going. Right, moment of truth. I've got the power cord plugged in. We'll turn the power on. We'll push the button and see if it boots. I'm 99% sure it will. We have 6 watts. Before we had 5.5. So it's actually plugged into the motherboard now, so it's doing slightly more. Because motherboard's obviously using a little bit of power. Minuscule amount. Right, push the power button. It's booting. Putting out 94 watts. I don't know if the computer still works, of course. The power supply is working now. Lights on, very dim. I'm hoping the hard drive still works. Power's dropping down to 70 watts or so. It's fluctuating slightly. It's doing something. Okay, well, it looks like it's working. It didn't go bong, but then it could be because I had the volume turned right down it when I put it away, because that will retain that setting. Although, mind you, I've taken the parameter RAM battery out, so it's got no PRAM. So maybe it should have bonged. I think I need to hook up a screen and a keyboard and stuff on this, and we'll try it out. But the lights on, solid. Yeah, okay, it's just no bong, that's all. So I shall just give it a minute and I'll kill the power, I think. Right, I've hooked up a screen, keyboard and mouse. Let's try powering this again. Turn the power back on. Hopefully the VGA signal comes up. If not, I've got some other problem. Oh, something's happening. Oh, no signal. Again. Oh no, something there. There we go. It's booting. I'll turn this off. I don't know what size screen I had on this thing before. I mean, this is 16 years ago. and probably last time I used this computer, so I'm not sure what's going to come up. I don't know if the login's going to come up, or even if I can remember what the password was. Even if it had a password. OS X, okay, cool. OS 9 or something. Have a mouse. Clock is wrong. Get rid of that. Got a mouse. Still booting. It's very slow. Imagine that. I've got a 320GB hard drive in here. Yeah, it would have been big for that time. Jeez. Okay. I think I have a working machine. Well, rather annoyingly, I've got it all logged in now, obviously, and my programs aren't here. So the software I use to write the program I'm trying to fix, not installed. The program which I need to fix is not on here either. So my hope was that it's all on this machine and I could get this machine working and then fix the problem with the software. And it's not on here. Damn. Now, according to the file dates on this thing, last thing was used 2011. So it's been 13 years since the machine was used. I just wish I knew what happened to all the software and everything. I'm not sure which machine I did this on now, but the software is not even on this one. So it may be a machine before this one. Yeah, what's actually got 256 megabytes of RAM. It's a 1.2 gigahertz PowerPC G4. It's like 1.2 gigahertz, running 10.4.11, which is the highest this could go. This has got the upgrade in it for the CPU, so this is, I think this is as fast as it could go as well. So it's all upgraded quite a bit for what it could be. But unfortunately, the stuff I need isn't here. This monitor's filthy as well. Yes, I know. This is also in the garage because I need a VGA monitor to plug into this machine. So at least the monitor worked, and the machine's working now. So yay, I fixed it. Anyway, so at least I've got the machine working. It's just unfortunate the thing I'm trying to find isn't here. Oh well, catch you later. So today I'm going to look at this Mac Pro. No,